Okay, team. Now, what you're seeing is M65, M66, uh, the Leo triplet in the Leo constellation. So you see a small smudge here. This is the galaxy, and this is another galaxy. And I don't know if you can make out some fuzziness here. This is the third galaxy. So these three galaxies together are called as Leo triplets. So let me just show you how do you get these Leo triplet. So you're seeing the Leo triplet here. It is called as Leo triplet because it is a combination of three galaxies. Uh, this one here is M65. This one is M66. And then I don't know if you can find out the smudge in this zone. So it is almost like a isosceles triangle here at this point. That is a hamburger galaxy. So let me just show you on the uh, simulation how do they look. So here is the Stellarium simulation. So so you can see we are looking at the Stellarium simulation, and in this simulation you can see this. I have just pointed out to the Leo triplet. So this is an inverted image because I'm using a Newtonian reflector, and you can notice now this is M65, that's what it is pointing to, and then we have an M66 and then the hamburger galaxy. So these are the three. So if you see, all the three galaxies are all spiral galaxies. In fact, this one, if you notice this, you can see a barred shape coming up. So there are two prominent uh, the arms of the galaxy, and then they emerge out to be uh, like a bar. So now, how do you find out this? So if I zoom in, by the way, this is the simulation. This is not live from my telescope. So you saw how does that look in the telescope? This is how it has been captured from the Bangalore cities. Okay, so you can notice that these images require a lot of efforts and a lot of processing. So all those images that you usually see on the photographs, uh, and get fascinated thinking that I would be able to see galaxy in this way through a telescope. That's a myth. So let's look at this. So one of the Leo triplet M66, this galaxy is a barred galaxy. How do we know that this is a barred galaxy? The first one is you can notice it through the shape itself. So it does not have multiple uh, arms. It just has two major arms. So the first one, second one, and the bar emerging out. And you can also look at it when you see the galaxy type here. It says galaxies type is SB. So that's a barred galaxy, spiral barred galaxy. So it's easy to identify. And when we go to the uh, M65, even M65 is a spiral barred galaxy. So you will see that. Okay, but this is less barred than the previous one, M66. While these two, you can just look at these two galaxies as a tilted version of a face-on galaxy, and this, the hamburger galaxy, the one that you're seeing here. If you now notice this, uh, this is actually on the line of sight. So you are seeing as a vertical line and the dust lines in the galaxy, and this is typically because the galaxy is seen as an edge-on. So we call this as an edge-on galaxy, and you can see that the name is Hamburger Galaxy. NGC number is 3628. But these are popularly known as Leo Triplet. So these are three galaxies. And when you actually look through a telescope, you will be able to see the galaxy something like this at this level. So you will notice that the Hamburger Galaxy, this is edge on, and these are barred spiral. You will be able to notice these shapes. So that's the best part of it. Okay. Let me now take you to the next galaxy, and hopefully you're going to enjoy the next one. So I'm going to keep this here and moving the telescope to the next galaxy. I will show you the image first, and then you can guess which galaxy it is going to be. Currently, I'm moving the telescope to the specific location. Let's hope we see a good image of the next galaxy. The images are being captured. It's a long exposure, so I have to wait till the images are 100% captured. Okay, I'm hoping that you can see some details here. Okay, this is the zone where the galaxies are, and by the way, uh, I'm sure somebody would have realized now which galaxy I am looking at. You're looking at. If you did notice, you can just put up the name of the galaxy. Which galaxy do you think is this? Okay, this one is called as uh, the Whirlpool Galaxy. So the Whirlpool Galaxy has a different shape. So let me show you the Whirlpool Galaxy. It's also called as M51. So here you notice the Whirlpool Galaxy is in the constellation Ursa Major. So if you have to identify this Ursa Major constellation, you can look at it this way. So you have the pointing stars to the North Pole, so these two stars, and then the seven, the Saptarishi Mandala, the seven stars. If you go to the last star, uh, it's almost like a 90-degree from this last star. So you can easily find out that. And there is one more galaxy exactly opposite. This is called as Pinwheel Galaxy. I'll show you that as well. So that's another interesting one. Let's first look at the Whirlpool Galaxy. So the Whirlpool Galaxy, yes, this is the Whirlpool Galaxy, and what you are looking at now. So you can notice that there is a spiral arm. So this is a spiral. Of course, this is a spiral galaxy, but this is a special case where we call it as a interacting galaxies. So these are two galaxies interacting with each other, and they are actually merging with one another. And it may take a few million years to merge, and once they merge, they become a bigger galaxy, probably a globular, as many galaxies merge together. So even though the bigger galaxy in the whirlpool is a spiral galaxy, we typically make this the combination of these two galaxies, which we call as a whirlpool galaxy M51. We consider this as a peculiar galaxy or a irregular interacting galaxies. Okay, so these are interacting galaxies. And yes, this is a spiral galaxy, but when you look through a telescope, of course, you can see something like this out of this size. With larger magnification, you will be able to distinguish the arms. But this is how it will appear in a telescope, which is like 8-inch, 12-inch. You will be able to notice that there are two interacting galaxies and the spiral arm. And the same thing I am showing here. So if you notice, these are the two galaxies. And this is not a processed image, and also this is from the place where it is a lot of light pollution. I am right now at the Bangalore city. So obviously you will see, uh, what is this? You will see that this particular image is very dull. But if the same image were to be taken from a remote location, let me show you one of the images that I took from a remote location, the same Whirlpool Galaxy, but from a remote location. Uh, how does it appear? And after a small processing, how would it look like? So this is how it is going to appear. So I hope you can see this now. So this is the same telescope, same camera, and the same setup. Uh, and you can notice that the spiral arms are visible. The interacting galaxy is visible. So this is the M51 that I was talking about. So you can see that the spiral arm is clearly visible. The dust lane is visible. Uh, in fact, uh, if I have to show you a negative image, uh, I somehow like the negative image of the same picture. So let me show you. Here is there's a black and white version of the same image. So now you can see that this is the same Whirlpool Galaxy that we are talking about. Uh, and you can clearly look at the spiral arms, the uh, interacting part of the galaxies, the dust line, and then the core of the two uh, galaxies interacting. So this is your Whirlpool Galaxy, and this is a 30 seconds exposure from a remote location. So I'm going to show you the image which is on the simulation, Stellarium, which could probably help you understand the structure better. So I'm going to place it side by side so that you can look at it. So see here. I hope uh, you're able to see the shape, and this is exactly the same image, the Whirlpool Galaxy. If you get a chance to look through the telescope, typically to see all these Whirlpool Galaxy and the shape of these galaxies, you need at least an 8-inch to 10-inch telescope. So a lot of people keep asking us what is the best telescope to buy and all. Please make note that telescopes are like buying a camera or a car. You need to do a test drive before you actually buy them. Otherwise, you will end up just listening to somebody, and it may not suit your needs. So it's always better that you test drive your telescope, which means be part of the association, look through the different telescopes the members have, experience it, and then decide what is the best one for you, rather than randomly planning to buy and jumping to buy the telescope. Uh, then let me just go back and list the telescope. Let me just go back and point to some other object. Okay, so right now this is the galaxy that we were talking about, M51. I will try to see if I can take a longer exposure. A longer exposure means we need to go ahead and expose it for a pretty much higher time. So let me see if I can expose it to a higher time and get a spiral arms visible, which requires uh, some bit of time. So let's give it a shot now. Uh, yeah, Akash was asking, I see some of the stars within the dust line. Are they part of the galaxy itself? So let me just show you the image again. Uh, I think they are just the foreground galaxy. I don't think foreground stars. I don't think they are part of the uh, galaxy. So this is, if you notice, those are all the foreground stars. I guess they are not part of the galaxy as such. And I somehow like this negative image more. Yes. Okay. Um, by the way, some of the people were asking about the previous image I displayed, which was a cluster. That was a globular cluster, actually. Okay. So you can see here, I have just increased the magnitude, and it is just a quick view. Let's see if I can get the magnification on that particular part. So the telescope that I'm using is a 8-inch Newtonian reflector. Uh, okay. So here, this is the image that I'm trying to open. So you see this? Okay. I've just zoomed into the that segment of the galaxy. Let's see if I do some processing, if it brings out some feature. Wow. Can you see the uh, I think you can see the color, I mean spiral arms now. So let me just increase and just applying some corrections so that it is, you can see it. Yeah. At least I think you can at least see the spiral structure here. One of the spiral arm coming up here, second spiral arm coming up on the top, and then this is the second galaxy. Uh, yeah, you can still make a beautiful look at it. Uh, I can actually go ahead and increase the exposure settings, but that is going to whitewash the image. Let's see if I can make some processing out of it. Though I'm not using any processing software, I'm just showing you the raw images as of now. So this is how. This is just about 30 seconds exposure that you are looking at right now. So I hope people realize that it is not just looking through the telescope. So when you look through the telescope, uh, you don't expect that the telescope is going to show you all beautiful images and then the structure of the galaxy. It is basically a processed image. So I'm going to just so this is the next image that I just now took. So let's see if I can, if we process this, how is this going to be? I'm just going to convert this so that it is easier for us to recognize the uh, shapes. So you can see now uh, there is some bit of spiral structure that you can see of a galaxy here. So you can you can still see the Yeah, the structure, I mean, the spiral arms is visible, but unfortunately from the Bangalore city, this is what uh, we can get as of now. And you need to capture a lot of images, like a few hours of exposures, and stack them to get a beautiful picture. Okay, now that we are done with this particular image, galaxy, so let's go to the next object. The next object that I would like to show is, uh, hold on, for people who had missed the moon today. So here is a moon image. Just keep having a look at this moon. I'm going to come back and uh, point out to the next object. Okay, this is the next the star that I'm going to show you. This is the Saptarishi Mandala Mizar, and it's a binary star. So visually, you will see two stars. So basically, what you're looking at right now is a live picture, live feed, and I'll show you uh, an image of this, which will be awesome. When I capture an image, it is going to be awesome. So what you're seeing is a two star, one star here, the second one here. And if you go out visually, you will be able to distinguish these two stars in the night sky. And these are the two stars, Vasista and Arundhati. It is in the Saptarishi Mandala. So let me just show you where this is, where the star is. So here I'm showing you the, yes, I'm showing you the Stellarium simulation. So when you go out in the night sky and then look in the direction of north, so this is the pole star. So this is the pole star. So let me just show you. Okay. So, so you can see this. So this is the ground. This is the ground level. And from Bangalore, you will notice that the pole star is approximately uh, 13 degrees above the horizon. And this pole star is part of what is called as an Ursa Minor constellation. And to identify the pole star, all you need to know is you just have to go and identify these two stars here. So you can notice this. There are two stars here, and these two stars together point to the pole star. So these are called as pointers in the Ursa Major, and the lines that you can draw is to identify imaginary lines. So this is the pow. So now this second star from the tail, that is where we have the binary star. So this is a double star. But what happens is when you zoom into this and then try to look into it closely, so you will see that this is the binary stars, which is visible to us. So you can just imagine this. This is the, let me just put it into a tripe equatorial mount. Okay. So this is This is on a equatorial mount, and okay. So this is the settings that I have on my camera. So if you see this particular frame, this is how the current picture is going to look like. And when I show you the live image, so you can see this. There's one star here, the second star here, and the third star, which is a dim. So that's exactly what you're looking at in the frame. The center one star, the second one, and the third one. So these are the three stars which are prominently seen. So you can see these three stars. But then, what I want to highlight is, even though these two stars are visually seen and these are called as visual binary, if you go to each one of these stars and zoom in fact, this itself is a spectral binary. So they actually are three stars, and each one is a double double. So let's look at it. And when we go deeper, so you can see that there are two stars here. So can you notice that there are two stars now? So there are two stars here. These two stars, uh, these are again, uh, you can resolve them through a telescope. So let me go ahead and show you these two stars, which looks very close to the first one, the Mizar. Okay, so remember, I'm showing you three stars here, the first one, the second one, and the third one, and I'm going to the Mizar star, and when we zoom into it, you're going to see two stars. So just be aware of it. I'm going to show you in my live view how is this star here going to resolve into two stars when I zoom. And uh, I have just took a picture of this star. So let me just show you that. So these are the stars. So I hope you can see this. So these are the three stars that I was talking about. The Algol and Mizar. Not Algol and Mizar. Yeah, Algol and Mizar. So now you see the star 1, star 2, star 3. And this one, by its look, the moment you look at it, a keen observer will immediately realize that there are two spikes that you can see. The two spikes actually indicates that there are two objects that are sourcing in. So if you see at this point, for this star, there is only one spike, but for this one you will see two. So let's look at it. And in case if I have a, a issue with focus, it will show up. The star will not be in focus. So let's try to check on that as well. Okay, so we're going to see the binary stars in Ursa Major now. Yes. So you can see the stars now resolved. So this is the two binary stars that I was talking about. So now you can clearly see that they are resolved. Uh, and if I reduce the exposure, I mean, the settings, it might give us a better image or a clarity. Let's see. Okay. So you can clearly notice that it's a binary star now. And each of these stars are also spectroscopic binary. What do you mean by spectroscopic binary? In the spectroscopic binary, the stars are not resolvable by a telescope or through visual. You have to take a spectrum, and the stars are so close by that it is visually difficult to separate them out. So that's called as spectroscopic binary. This is a very interesting object. So you saw two binary stars, and this is how the binary stars are interbound uh, together through gravitational forces among themselves. I can also just go out and indicate the other part, which is there are multiple types of binaries actually. Uh, One is called as visual binary, which is what we see visually. So when you look in the sky, almost 60% of the stars are all binary stars. Let me show you some of the famous stars that you have heard of, and they, I'm sure you will be surprised that most of them are binary actually. And then the binary could be just because of a line of sight, wherein the first star and the second star is just in the line of sight and appear to be together. Uh, like a distant object and a nearby object, they appear to be close to each other visually, but in reality, they are far away. So those are called as non-gravitationally bound uh, visual binary. But then there are gravitationally bound binary stars, uh, and those gravitationally bound binary stars go around each other. So they will have an orbital period for them. So each one will go through the other, and they both orbit along the center of mass. So when there is the the two binaries which are gravitationally bound, they go around their center of mass and have an orbital period. And if they are in line uh, to our line of sight, which means their orbit is in line. So let's assume that this particular binary star is going like a circle. Okay, then at any given point of time, we will be able to see both the stars because it's going in a circle, and that is called as face on view. That means we are just looking on the face. But just imagine if this star is going round and it is going in the front and the back. In such case, what happens is at some situations, the star is completely behind the primary or the bigger star or the first star, and then it comes and blocks the star. So there are situations where the first star is eclipsed and then the second star is eclipsed, and they both go through a cycles of eclipses. Depending on the brightness of each of these stars, depending on the size of each of these stars, you get an eclipsing binary. And eclipsing binaries are very interesting because by studying eclipsing binary stars, you can get to know the atmospheric conditions. Uh, you will get to know, I mean, you can study the atmospheric conditions because one of the star, I mean, the compositions, the if it contains any uh, cloud around it, there's a lot of studies, and especially if you have a eclipsing planet, then it becomes even more interesting to study the uh, planetary atmospheric conditions. Okay. In fact, a lot of planets which fall under a category of hot Jupiters, they orbit the planet, they orbit the star uh, very close to each other, and such weather conditions can be studied by the eclipses. So this is a eclipsing. I mean, this is a star. Is this eclipsing binary? The answer is no. There is not an eclipsing binary. Okay. Uh, And then let's. I think we are just good to go with this. So the one that you saw is focused on this part of the object. Uh, Let me just go ahead and show you the image. So this is the image. So you can see this image, and these are the two stars. And you'll see the spikes on the stars here, and that's because I have a Newtonian reflector and the secondary mirror that reflects the lights to the eyepiece. It just reflects the light of the star falling, and hence you get these spikes. It's basically the physics part. Okay, so while you enjoy this one, I'm going to go ahead and get the another object, and the next object is a very interesting one. This goes to Sudash, who just helped me show it. Even though I had ignored this, I think this is the next object is going to be an interesting one. So let's hold on for it and then check. So while you enjoy this and study more about Varundhati Vasista, and for those people who remember that during wedding time, you're supposed to show Varundhati and Vasista, I think you can show the actual Varundhati Vasista nakshatras now. So please go ahead and show it while I go grab the next object for everybody. Okay, the next object is ready, and while I try to capture the next object, I will just leave it for you to enjoy this one. So right now I'm capturing the image. Okay, so this is actually a pole star. So now you can see the pole star here, and the pole star is the one that is uh, that's at the close to the polar axis of this Earth. And the more interesting one is uh, in the last virtual star party, though I had not given an importance to this, this appeared to be a very interesting one. So you can notice that Along this pole star, there are few stars which forms like an asterism here. The pole star here, the first star, the second one, third, fourth, fifth, sixth, seventh, and you see that it is almost like a circle. So this is called as a polar ring, and there's a circle of stars around the along with the pole star, and that's a very interesting uh, uh, object to see in the night sky, and it is visible from a dark location. So let's look at it. So where is it? This is the pole star. So if we zoom in into this pole star, are you able to see the circular stars? I hope I hope by now it should be clear. So you see these stars here forms a circle, and these are visible through a binocular. And that's where you can notice the polar ring. Yeah, and this is the pole star. So this is in the Ursa Minor, and one very interesting uh, fact about this pole star is from any location above the equator. So from any point above the equator, most of the times this is not going to set. It will almost be visible all through the year. So in Bangalore city, this is at 13 degrees north, and it is going to remain at 13 degrees north for all the time. Okay. Uh, Let me just go ahead and uh, show you one more. So this is the pole star, and again, let's look at it. So this is the pole star and uh, the 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 circular of stars, the circle. So these are the stars. Okay, so we have seen the circle of stars. Now I'm going to go ahead and show you the next object. The next object that I would be showing is a Pinwheel Galaxy. So I'm going to just say it across. So what is this Pinwheel Galaxy? Basically, the Pinwheel Galaxy, this is how the Pinwheel Galaxy looks like. So let's go ahead and I'm going to go point the telescope to this. I know it is going to be difficult for us to capture this from Bangalore city, but let's see if we can get some smudge or identification of a pinwheel galaxy. So probably we will be seeing something like this. So this is the frame. So it should be visible like this. And it don't get carried away with this big structure. We might want to just look at it in a uh, best possible way. So let's give it a try. You can hear in the background the telescope is moving. Uh, that actually indicates, I mean, I have just given a command to move to the uh, Pinwheel Galaxy. So let's look at it if we can point out to this. This is a Pinwheel Galaxy. And if you notice here, in this Pinwheel Galaxy, uh, it is also called as M101, M101. Uh, One of the distinct feature that you can see is you have the core of the galaxy, and then the spiral arms are visible very distinctly. You can literally count the spiral arms like one, two, three, four, five, six. There are multiple spiral arms. And this spiral arm, you will see that there are a lot of NGCs written here. There are small boxes. These are all the objects on the Pinwheel Galaxy, wherein most of these are clusters. And these clusters, okay, so this is like a hydrogen emission zone. This is probably a cluster of star forming regions and clusters. So what happens is the new stars are being born in the spiral arm. So you will also see that in even in our uh, Milky Way, there are a lot of there's a lot of what do you call uh, hold on, let me just go to this. There are a lot of places where you will see star birth region, like Orion Nebula is one of them. So the star birth zones or star birth regions, that is where a lot of uh, interesting actions are taking place. Uh, the clouds are getting uh, gravitationally bound and squeezed so that new stars can form in. The emission of uh, the emission from this new starlight bounces off from the interstellar medium so that we can study the interstellar compositions. A lot of interesting things that interest physicists, they're astrophysicists. Okay, so I have just taken a picture. Let's see if the telescope pointed it to the center. Okay, so this is the area of a pinwheel galaxy, and I can see some small, yeah, I can see some small smudge over here. So I'm just trying to zoom in. So if you see this particular region, this is the point where I see some smudge. So if I zoom in into this particular area, I can see that this could be a potential galaxy point. Okay, so let's look at it. The best way for me to do it is I'm just going to convert it into negative zone, and then yeah, see here. I'm hoping that you're able to see the kind of structure here. This is the galaxy core. So that's a pinwheel galaxy. Let me see if I can get some. Okay, so this is the galaxy. You can see some of the structures. I mean, the smudge around it. At least on my computer, I'm able to make out some small structure. So what I will do is I'm going to increase my ISO and see if I can get some more data onto this. So this is the uh, Pinwheel Galaxy, which is this one. Okay, so we are looking at this galaxy here, this part, and this is the live picture captured, and we have the Pinwheel Galaxy shape. Let's see. Get the next image. Probably we might get some data out of it. This is the word. Okay. So this is the, let me highlight the zone. In this zone is where I'm finding the galaxy. So I'm just going to see if we can get some data there. Okay. Are you able to see the changes? The spiral arm almost extending up to this point here. And this is the galaxy. Yeah. So this is a Pinwheel Galaxy. For people who have just joined, this is the image, reference image. Uh, so this area. And it is a beautiful image. You will be able to make out these spiral arms if you go to a dark location through at least 8-inch, 10-inch telescopes. It's a good image, good one. But you're not able to make out the structure here because of the Bangalore skies and light pollutions. So let's move on to the next object. And in the next object, I'm sure you're going to see a beautiful structure and it will be prominent. So let me just jump on to the next one while you enjoy this image, which is called as Pinwheel Galaxy. Okay. So for people who are observing, I would also ask you to just search on these names on the Google. You will be able to read out uh, more information while the telescope just keeps moving to the next object. So don't miss out on that. Okay, the next object is ready. Uh, the next object is, let me just show you the object and see if you can identify the object. Okay, so here is the next object. I'm sure by now somebody would have understood the object that I'm going to talk about. So here, I hope you got the object. Uh, okay, so this is called as the Sombrero Galaxy. So this is a Sombrero Galaxy, and let me show you the image of Sombrero Galaxy. So let's go to Stellarium, and here I'm going to type on Sombrero Galaxy. Look at this. Look at this. So I hope you're able to make out the shape here. So this is the dark lane and then some bulge of the galaxy. So that is what you're seeing here, the dark lane. And then, yeah, so look at this. Yeah. So this is the Sombrero Galaxy. Both. So you will see that there is a dark lane here, and that's exactly what is captured and seen. Um, this is the latest image. So I've just got it to the center. So if you see this, I hope you can make out the dust lane and the core. And this is the Sombrero Galaxy. It looks like a hat, basically. So this is the Sombrero Galaxy. Uh, in fact, uh, when you look at it through the telescope, it really uh, gives you a very beautiful hat kind of a structure. And a small telescope is more than sufficient to enjoy this object. So let me just process it a little so that it might be useful for you to look at it. So I hope you are able to see this now. So this is the Sombrero Galaxy from the picture. I've just highlighted a small portion of the area wherein the galaxy is and the shape of the galaxy. Uh, I hope you will be able to relate to it now. So this is the Sombrero Galaxy. It appears like a sombrero hat, as simple as that. Uh, now, uh, if you notice, this is also a spiral galaxy, but then the spiral galaxy is on a edge-on view. So this is an edge-on view of the spiral galaxy. And you see the bulge here, that's a bulge of the galaxy where you see a lot of stars being present. And the dust line is the one that is blocking the light from the galaxy. These are the interstellar medium. Uh, now that we have seen this, I'm going to now go ahead and select a few globular clusters. Okay. So globular clusters are those which are a group of stars which are available. By the way, this one is called as this was in the constellation of Corvus. So let me just show you where this constellation is and how do you find this particular Sombrero Galaxy. So here is the location for you. The best way to do it is to go through the stellarium. So you see that Corvus. How do you find Corvus is if you have the uh, galaxies marked. So let's see this. So this is your direction of north. So you are in the direction of north. So turn to the southwest. So this is west, turn to the southwest. So you have your 90 degrees turn and then another 40 degrees, 45 degrees. So at this point, if you go look up, you will find this kite kind of a shape. So if I remove the shapes, it will be much easier for you to understand. So there are 4 stars here. 1, 2, 3, 4. So this is like a kite. And when you have the imaginary lines, so these are like, I mean, here it is giving you like a parallelogram, but then uh, when you take the two opposite sides of the constellation, Corvus, and you extend these two, almost at the same distance between this, you will find the Sombrero Galaxy. And in fact, in the binoculars, you will be able to see this galaxy. And for people who have the binocular, all you have to do is look in the binocular for this star and this star, the two opposite side of a star, and then extend it, you will find this galaxy. And don't worry, in case if you make a mistake, example, you took the other 2 stars and you went down, you will see one more object which is called as a globular cluster. So this is what I'm going to show you. What is the globular cluster M68? So you'll see that globular cluster will be like this. Okay. So you have on one side you have a globular cluster and the other side you have a Sombrero Galaxy. Both have almost the similar, like take the opposite sides of the stars and then extend it, or take these 2 stars and extend it. Okay. There is one more Pinwheel Galaxy. It is called as Southern Pinwheel. And this also looks very similar to the one that I showed you previously. So you see this Pinwheel Galaxy, very similar to the one that we saw in the Ursa Minor. Okay. So let's go ahead and first look at M68. So I'm going to go ahead and point to M68 and capture an image of M68. So let's hold on for getting an image of M68. So you will see a lot of stars in this area. This is the image of the M68. I know it is very difficult for you to understand where is the globular cluster. So let me show it to you here. And when I convert this into a grayscale it will be much more easier for you to understand. So I hope you can see the cluster a lot better now. Okay, so that's the globular cluster. And what you see is the globular cluster has a lot of stars which are gravitationally bound, and they are very compact objects. So when you look through a telescope, you will see a lot of stars. Each of these blur areas that you see here around the mouse, each one is a star. So this might contain a few thousand, few lakh stars within a short region. Yes. So, so this is the globular cluster. And as I showed you in this stellarium, this is how the globular cluster is looking at. So to confirm that what we are seeing, if I take the size of my camera, so you see that the size of this globular cluster is so small when compared to the whole frame. So it's a very small image when it compared to the whole frame. Okay. And that is why I had to zoom and then show you the M68. So this is the globular cluster. So you can see the globular cluster both together. So what I'm going to do next is I'm going to go ahead and show you another globular cluster. So, while you enjoy on this, uh, the other globular cluster that I'm going to show you, I'm hoping that this is going to be a useful, an interesting object. So let's look at it. In fact, the next object that I'm going to show is one of the most loved object in the sky. Many amateurs like it. It's also one of my favorite objects among the many clusters. So, and that is Omega Centaurus, Omega cluster. So this is in the Centaurus, and here is the Omega cluster. So you can see that this is also a globular cluster, but the amount of stars that you see in the globular cluster is so much. In this cluster, there are a lot of stars, and they are bound with a beautiful image. You will see the golden yellow stars. This is a breathtaking image if you look into a big telescopes. And I hope now you are able to understand. This globular cluster is so big. You look at the frame; it's filling almost half of the frame of my camera. So let me show you now the image. I know this is the what do you call the washed out image, but then when I convert this into the grayscale, you will get the image here. So I hope you're able to see this. So uh, let's crop this image and then I will show you. So you can see this uh, the full image. So look at this. Okay. So this is the globular cluster that we were talking about, Omega Centaurus. And this is just a 30 seconds live image that I have captured. Yes, of course, you are not able to see the the golden yellow color. That is because uh, it's not processed, and also I am just using this setup to show you different kinds of object in the sky rather than just capture it. So the objective is not to capture the object. The object is to show you how the different objects looks in the sky. This is a globular cluster, Omega Centaurus, one of the beautiful, and it's a naked eye object. You can actually go out, and it is in the south. So if you see it, it should be visible from a dark location. From Bangalore cities, by a binocular, it is a very easy target. So if you have a binocular, you should go out and then watch it. So where is this located? And again, I'm going to go out. So we saw this. There was a corvus. So remember this corvus where we spoke about the Sombrero Galaxy and the M68. So all you have to do is you look at this. So take these two stars, get the M68, and continue the same direction. Go down. So as you continue to go down, you will find in the binocular view you will 100% find the Omega cluster. That is the Centaurus. Uh, within a short within a short move. And this is, you will never miss this object in a binocular. Okay. And then here is another Centaurus A. I don't know how many of you have heard of this Centaurus A uh, uh, galaxy. This is actually a galaxy, Centaurus A. But this Centaurus A is a uh, active galaxy wherein uh, the core of this galaxy is where the first of the uh, what is called the black holes were identified. Yeah, Centaurus A is one of the places where the black hole was identified in the early stages. Okay, can I take a picture of this? Unfortunately, my resolution, my camera, the telescope, I don't think we will be able to take out a picture of this. So I'm going to skip this part. Uh, I'm looking at probably a open cluster that would give you some interesting object, but unfortunately, this is the place of the sky, which is filled with globular clusters like this rather than a open cluster. Here, this one looks like an interesting globular cluster. Another one, so NGC 5986. So let me just go ahead and point this to NGC 5986, the 5986 NGC cluster. Okay, this is Omega Centaurus, and I'm going to go ahead and point to 5986. So let's see this 5986. The telescope that I'm using is a Newtonian reflector, 8-inch. Uh, Let me show you my telescope. So this is a 8-inch Newtonian reflector. It's on an Celestron Advanced VX mount. And some of you are able to see that there are a lot of meteorite falls on the screen just because I have set that meteorite fall to a maximum number. That's why you're seeing it. Okay, these are the this is the telescope that I'm operating. So you can see this. This is my telescope, the uh, advanced VX telescope, 8-inch Newtonian reflector. There are two of them. Yeah. So this is a telescope that I'm operating right now. Okay. Meanwhile, I have pointed the telescope to our what is this 5986 cluster. I'm now going to go ahead and take a picture. So let's see how the picture is going to be. I have purposefully overexposed it so that I can convert it into grayscale and then edit it. So I hope you are able to. Let's let's look at this. I hope you are able to see this now here. This is where we have the image. So I'm going to just crop it to that, and it becomes easier for us to see it. Yeah. So if you now look at it, this is the globular cluster, uh, the one that we just now captured. And this is NGC here, 5986. So you can see this when it is compared to the whole frame, the object is very small one. So that is why I had to crop it, and the cropped image is this. So this is the cluster. This is the globular cluster. And you can notice that there are a lot of stars in a small region. Okay, so the next one that I'm going to show you is uh, we're going to go here and let's look at this. So this is uh, the M80 globular cluster. So M80 globular cluster is visible, so I can move on to that. Just remember this, it's an M80 globular cluster. Okay, and now we are entering into Scorpius. So this is the Scorpius zone. So this is a beautiful area. If you want to take a picture, a long exposure of this, this is one of the delight object. So we're going to go ahead and then capture this M80. And as you see the image size itself, compared to the whole image, this is going to be a small object again. The telescope is moved. Uh, while you enjoy this globular cluster, I'm going to go capture the next image so that uh, we can look at it. By the way, I only spoke about the telescope. The camera that I'm using is a Canon 6D Mark II, and the Canon 6D Mark II camera has the capability to connect to the laptops, and I can remote control it. So it gives me an opportunity to download the image as well as share it with you. Okay. So this is the picture of M80. So now you can see that in the whole frame, the object M80 is so distinctly visible. While we were struggling to uh, see through the galaxy shape, clusters are very visible because each star is a source of light, and hence we are capturing the photons from them. It's better than a fuzzy object. So so look at this. So let's just crop this much. This is going to be the cropped view. This is a M80. So let me just make it better. Okay, so you can see the M80 cluster, and this is how different objects look at. If you look at the sky, this is now the M80. You see this globular cluster, and through the Stellarium also, I was showing you the same. So you see this. We just cropped uh, the image to this much. Okay, so we saw this M80. I can't take the next object, which is M4. That's a globular cluster again here. Okay, this one, M4, the globular cluster. But because there is a tree that I have which is obstructing, so I will not be able to show you this. Meanwhile, what I will do is we can go ahead and look at this globular cluster, which is the sorry, this is the Ophiuchus. So we can go ahead and check on the globular cluster M10. Okay, so let's look at globular test cluster M10. Uh, this this is also a very faint, I mean, a small size. So we're going to go ahead and capture the M10 globular cluster. So we are actually looking at a lot of globular clusters, and every globular clusters almost appear the same except for the position in the sky. And the telescope that I was showing, the telescope is a go-to telescope, which means the telescope has all the data of where the objects are, and hence it is easy for me to give a command naming them. Okay, here is M10, just go to M10, and the telescope is going to move there. Okay, so this was the previous photo. So you can see that all the globular clusters pretty much appear similar. This is the omega cluster that we saw. This is an open cluster. So this is an open cluster, while globular clusters appear as a compact object. Okay. So here is the M10. So you can see then, this is another globular cluster M10, and I'm going to crop it up as well. So see, I'm not using, I'm not taking pictures for processing them. That's why you're seeing them as exposures, everything is grayed out, a lot of differences. But when we actually take out for imaging, there's a lot of adjustments that will be done. And so this is M10, the globular cluster in Ophiuchus. So let me just, so you can see the globular cluster. You see the lot of stars. So of course, I'm yet to uh, uh, focus them because every time the telescope is moving, there's a lot of the camera weight, and then the focus is going to be missed out. So while we are doing imaging, probably I would spend like 1 to 2 hours only on capturing one of these clusters, and I would probably not go with multiple objects overnight. So this is M10 globular cluster, and let's look at how does it look in the stellarium. So you see this here. This is M10, and it's pretty much beautiful. So M10 globular cluster, and this is the frame that we are looking at. How big my camera frame is, and the the size of the object M10. Okay, uh, let's go to the next object. While you enjoy this one, I'm going to go ahead and find out which is the next object that you want to go see. The next one is just very close to this cluster, which is called as M12. That's another globular cluster in the same constellation of Ophiuchus. So we're going to go ahead and see M12, a globular cluster. Okay. So just M12 globular cluster coming up soon. So right now the sky conditions are clear. It's surprising that we are getting a clear sky during the month of May in Bangalore. After this is the time where you see a lot of globular clusters. This is the time of the year and the month uh, where globular clusters are very easy. So the next object coming up is the globular cluster. So you can see this. This is the globular cluster M12. This one is M12 globular cluster, and then this one is M10 globular cluster. So you can notice that they are pretty much the same size. And how do I know that these are two different objects and not the same? You can see the star positions here. There are two stars here. Uh, Probably if I zoom in, you will be able to see. You see there are two stars here, but uh, when I go to the next object, those two stars are missing. So this is a different cluster. I mean, the shape itself will be different. So the different clusters. And I know you can see that there is some shaking happening. That is because when I was clicking the camera, it's just I just shook it. Okay, I just tested so that and it just shook. I'm just capturing one more image now of the same picture. Okay, so we have done with M12 now. Uh, I can just go on with few more uh, clusters. So let me just check if we can go with the next one. Okay, let me just show you this picture before I move on. So basically what I'm doing is just to highlight the picture, I'm just converting them into a, yeah, just ensuring that you get to see the cluster. So this is the cluster that we were talking about, M12. Okay, the previous one was a little shaky. This is not. Okay, so the next one, let's see if I can get this particular cluster. This is another globular cluster, a bright one. So it should have some bright stars around. It's M5 rose cluster. There are a lot of objects that are coming up. So for people who are present online, just be there. I'll show you a lot of interesting objects, and that would certainly help you. Okay. Uh, the next object is the rose cluster. So I'm going to capture the rose cluster. Do drop in a chat message so that I understand you are observing your online. Okay, this is the next the next object. That's a rose cluster. So let's look at it. As I told you, I've just converted it into a grayscale so that you can easily notice. So I hope you are able to see the cluster now. This is a globular cluster, the M5. And if I have to zoom in, you can see that there are so many stars, and each one of these dots is a star. In fact, each one of these areas, this is all stars. I'm sorry. So this is M5, the rose cluster. So one thing that you have noticed is all these globular clusters, they appear the same. Uh, they have a similar, what do you call, feature. They have a dense collection of the gravitationally bound stars. Okay. Um, the next one that I would like to show is okay. I'm gonna uh, go ahead and show one more one more cluster, and then probably I'll move on to some galaxies. So this globular cluster, uh, if I position them correctly, I should be able to get two globular clusters. Let's see if I can position them in such a way that we get two. M53 is the next globular cluster. M53. So you can see, you can hear that the telescope is moving, and yeah, you just wait for the telescope to move and get prepared for the next one. I have the next cluster coming up. So let me again convert this into black and white. The only reason why I'm converting it into black and white is it's easier for us to see the stars. Uh, See here, this is the globular cluster, and you can notice it's very easy to identify a globular cluster. So here is a globular cluster. This is another globular cluster which is M53. But what I told you is, like, if I can get this globular cluster in a position, we can see two globular clusters in the same frame. So let me just move this globular cluster in such a way that the objective is, if I can uh, move this globular cluster to this extreme end, it is going to give me another globular cluster on the other side. So let me just try to see if I can position this correctly. Uh, and then I should be able to see a globular cluster. So I have just positioned the telescope on a rough note. Let's see if I have put the telescope in a right place or not. So I can only verify that by taking an exposure of a picture. So let's see if I can do it. And this is a faint star, so a faint magnitude 9.5 cluster. Oh, wow. Looks like I've got something. If we can see two clusters in the same picture, then it is done. So I have only one cluster here. So I think I have to move this all the way down to this point so that we can see it. Let me just check what best I can do. So just give me a moment. So what I'm trying to do is just to get two galaxies, two globular clusters in the same image. That's all. So here is the globular cluster. Before this, uh, we could see it this way. This is the globular cluster. So in the same field of view, I'm going to get two globular clusters. So I'm just trying to check it out. So here is the image. So this is what I'm trying to see. M53 is what we saw when it was in the center. It was like this. So I'm just trying to pull this into such a position that I can see these two. But I don't know how to get it. Maybe I need some reference star. Probably this star is going to be my reference. That's okay. I am unable to get the reference star probably because it is giving me some concerns here. I can either point it to it and then take a picture. Let me do one thing, 5053. Okay, the images are getting captured, so I'm just going to wait for a moment. I'm going to capture this 5053, so probably it will be like this. We may not get both in the same frame. Yes, you see it's very faint here. This is the object 5053. So let's convert this into our black and white, and then we'll be able to see the cluster. So all I'm doing is converting it into gray so that we can see it. So here, you see this is a globular cluster. Yeah, this is a globular cluster here, a very faint one. Okay, so let's go on to the next set of objects. The next object that I would be showing is uh, we are done with the what is this globular cluster. So let's go look for something else. Okay. Um, so what we will do is we'll go to yeah we'll go to the galaxy now. M90. So right now what I have is I'm going to capture Galaxy M90. So in this, I will be able to capture two galaxies in this field of view. So I'm just hoping that it's going to be something like this. So you have M89 and the M90, two galaxies in the same field of view. So this is the image that is going to come up. And this is in the constellation of Virgo. So hopefully we'll be able to see, if possible, a lot of galaxies. Okay. So let's wait for the galaxy image. Okay, coming up now. So as usual, let me convert this into grayscale. This should give us, wow, wow. I think both the galaxies are visible, and there are a lot more galaxies that are visible. So this is one of the galaxies that we were talking about, M90. This is another galaxy. Yes. So just to confirm, so we can just go on to our stellarium. See here. So we have this galaxy here, M90, M89. So M89, and this is the same image, M89 at the corner. It is always inverted, so it is going to be like this. So M90, M89, and then you're able to see some galaxy here, 12th magnitude, 11th magnitude, and this is all 12th magnitude. You can see some smudges here. So that's what I was just trying to understand. So, so if you see here, there are two small smudge coming up. You can see somewhere here. This could be a small galaxies, and we have the galaxies. So this is M90. Just to make sure that it's prominent and visible. Let's oops, let's put it up this way. You see this? This is the galaxy. This is the galaxy. This is the galaxy. All these are galaxies. There are a lot of galaxies. Okay, so let's consider only this part. I'm gonna crop it. Crop, invert, black, then yeah. So you can see that this is one galaxy here, M90, M89, and then some NGC galaxies. They are mapping with our M90, M89, and then the small smudge of galaxies here. Okay, so let's try to get in the next galaxy, which is uh, M58. So this should also give us another set of uh, twin galaxies, say Sun. Okay, so let's look at this galaxy now. Okay, M58. The field, the field that I am showing you right now, this is pretty much like in the sky. If you just take a 10-inch or a 12-inch telescope, and if you just move on, you see this. This is called Mercurian chain. You see the amount of galaxies in this place. Each one is a galaxy. We'll take this Mercurian chain as well. So let's see. And each one of it is a galaxy. Let's see if I can capture this. So let me first capture the previous image. That's M. This is the galaxy M58, and after that we'll go to this Mercurian chain. In fact, if you look at the Mercurian chain in the eyepiece, you will be able to resolve a lot of these galaxies. You will be able to count the galaxies, in fact, and it's a challenge how many galaxies you count within this one field of view. to. Okay. Since I'm unable to find where the galaxy is, let's go back and convert this into grayscale. Okay, so here you should be able to see this. Okay, so we are still able to see a lot of galaxies. Ah, this is beautiful. Okay, so the galaxies that were merging, those galaxies are also visible. I hope you will be able to see it. I am able to see it in the galaxy. So let's look at it. First, let me crop this so that we remove all the unwanted stuff, then convert this into gray. Then I hope you are able to make out this. Okay. I don't know how many of you are able to make out these small smudge here. This is that interacting galaxy. So when I show you the stellarium, you will be able to understand. So our objective was to capture this. So this is how our telescope is pointing to. So what are the objects that we see in this? What I have done is I have just cut this into this much zone. So what we see is this portion. So we have the N58. So that's our reference. And we will see that there is a bright star here. So let's look at that reference first. So this is the galaxy and then a bright star. So we have the galaxy and the bright star reference coming up. Okay. And then in the opposite direction, so you can see this. If the in this image, the bright star is up, so we have to go in the other direction. Look at this. Here, the bright star is up. We go in the opposite direction. Here, there are two objects here, small smudge. So you see this as I go in the opposite direction. This is a small smudge here, and you can feel this. You can feel that it is spread across, and that's exactly what is happening here. It is smudged like this. This is the galaxy, and this is one more galaxy. So all these are 3, 4 different galaxies here. So you can see the galaxies there. Wow. So we have captured M58, and also we have seen this smudge, the twin galaxies. This is again an interacting galaxy. Okay, now next, let's go to Mercurian chain. So in the Mercurian chain, I'm going to go ahead and point to, let's point to this NGC object so that it will bring the telescope into the center. So let's point to that NGC. Let's see. This is NGC 4435. So I'm going to point to that NGC 4435. I hope people who are watching it live are enjoying it and they're able to see a lot of objects. So I have just positioned that. Let me go ahead and take a picture. So we are going to see this current chain. So if I keep this as a center, we should be able to see these many galaxies. So there are a lot of galaxies that I'm sure we're going to see it now. Wow. So let's go ahead and check how many galaxies we can identify in this. Obviously, I need to go ahead some small. Okay, so I hope you are able to see some of the galaxies. Let's okay. So here you can see the galaxies now. This is a Mercurian chain. So here you can distinctly see one galaxy here. Okay. So this is galaxy 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. I could at least see 9 galaxies in this zone itself. So the the image is really bad because of the weather conditions in Bangalore, but I hope you got the gist of how interesting these objects could be when you look through the night sky. So you can see this is the galaxy. So let's put it a check. What I'm saying is, if you look at this, these are the two galaxies, the third galaxy, and then the fourth one. So the fourth one is like a horizontal line. This is like a, this is a horizontal and this is a vertical. So let's see if Stellarium also shows a similar object. So we said this is what we're going to keep it. You notice it's a galaxy here. So we have the vertical, horizontal, the merged. Yeah, pretty much we have Mercurian chain, the whole of the objects here. See this object, second one. Very interesting place. This is a Mercurian chain. Okay, so now let us go to the next object. Yeah, the next two objects I'm going to show. Then probably we will wind up our observation. I know it is getting late, uh, and I'm sure the next two objects would be worthwhile waiting for such a long time. Okay, so the next one is M57. So for people who don't know that, you go ahead search M57. So now I have M57, the Ring Nebula. So let me not hold on to your interest. This is in the constellation called as Lyra. This is the brightest star, Vega. Okay. So as we get into, this is how Ring Nebula is going to be. So basically, it is going to look like a small ring. Hopefully, we will be able to see some greenish color. Okay. I hope you got this now. Do you see a ring nebula here? So, in order to just make sure that uh, it's it's visible, I'm gonna just crop this so that it becomes easy for you to identify. And I'm gonna do the same thing, convert this into. You see this ring nebula now? So that's what we have, ring. So this is the ring nebula. Okay. I hope this is fun watching. So you can see both. This is the image captured just now, and this is the ring nebula, which is coming up from the Stellarium. So that's the ring nebula. Uh, the next one is I'm going to go ahead and show you a few more nebulosities like this, which could be interesting. Okay. The next one is going to be the Dumbbell Nebula. So let's go ahead and check if it is visible. Then the next one is going to be the Dumbbell Nebula, and uh, this should be visible now. Let me just put it up. So in the Dumbbell Nebula, you are going to see a dumbbell shape. So that's an interesting one. That the Ring Nebula, you are able to watch the Ring Nebula. The next one coming up is the Dumbbell Nebula, which is going to be something like this. So you can see the Ring Nebula has got a complete ring structure, but Dumbbell Nebula, there is no ring structure, but dumbbell structure. This is an interesting one. So let's wait for this. Okay. Sunil is asking, how am I streaming all these things? The answer is I have connected my laptop to the camera, and then from the camera, I'm just doing a screen share. So basically, I'm using a screen share on the Zoom application. So what you're seeing is the screen share. So here is a dumbbell. I know it is difficult to identify the dumbbell shape, but if I change the contrast, you should be able to uh, get it. So let's see if I can get the dumbbell shape. Um, I hope you're able to see that now. So here in the middle, that's the dumbbell nebula. So in fact, it's a beautiful object to look at. You can see the dumbbell shape here. Okay, and the the dumbbell is here. So this is the dumbbell shape, and the size that we are looking at is somewhere at this size. Yeah. So this is here dumbbell. So I hope you are able to see both dumbbell shape and then the nebula as well. So that's an interesting one. So Sunil, I hope you got the answer. I'm using the Zoom application screen share. My laptop is connected to the camera, and then the camera has a live view, and that's how it is getting broadcasted. Okay. Uh, so what is the next one? In fact, let's go to the next one. I think we have seen a lot of objects so far. Okay, we have seen a lot of objects. Dumbbell. Just searching which object is good as of now to look in the sky. Uh, I think that's it for now. There's a lot of objects that I've shown. The remaining objects are all going to be the next set, maybe some other time. But we have seen a lot of globular clusters, a lot of open clusters, double stars, and then the planetary nebula, uh, galaxies, a lot. So thank you so much. I hope all of you enjoyed this session so far, and look forward for many more such sessions and sharing. If you have any specific object, you can always post it, and we'll get back to you on that. Thank you so much for watching. Bye bye. Good night. This is Naveen Nanjanappa from Bangalore Astronomical Society. The location is Bangalore. Thank you.